Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Hello students, today again we will be learning the question based on the topic time, distance and speed. So our today's question is, a train covers a distance of 300 km at a uniform speed. If the speed of the train is increased by 5 km per hour, it takes 2 hours less in the journey. Find the original speed of the train. As it is given in the question that the distance covered by the train is 300 km and we need to find the original speed of the train. So let us assume the original speed of the train as x km per hour. Now we will be using the relation between time, distance and speed. So the relation is time equals to distance upon speed. Now as the train is travelling with the speed of x km per hour to cover a distance of 300 km, so the time taken by the train, which we will consider it to be t1 to cover a distance of 300 km equals to the distance travelled, which is 300, divided by the speed of the train, which is x km per hour, is equals to 300 upon x hours. Now as it is given in the question that if the speed of the train is increased by 5 km per hour, it means that there is an increase in the speed by 5 km per hour from the original speed of the train. So the new speed of the train is equals to x plus 5 km per hour. It means that we will add 5 km per hour to the original speed of the train. Now the time taken by the train when it is moving with the speed of x plus 5 km per hour is t2. The value of t2 will be equals to the distance travelled, which is 300 km, divided by the speed of the train, which is x plus 5 km per hour. So the value of t2 will be equals to 300 upon x plus 5 hours. As it is the time, so it will be mentioned in hours. In the second case, when the speed of the train is increased by 5 km per hour, therefore it will take less time to cover the distance of 300 km as compared to the time taken by the train when it is moving with the original speed of x km per hour. It means that the time taken in the first case when the train is moving with the speed of x km per hour is greater than time taken by the train when it is moving with the speed of x plus 5 km per hour. As it is given in the question that if the train is moving with the increased speed of 5 km per hour, then it takes 2 hours less to cover the journey, which means that the time taken in the second case is 2 hours less than the time taken in the first case when the train is moving with the speed of x kilometer per hour. Now, we can write the same equation as the difference of the timing. That means that T1 minus T2 equals to 2. Now, we will be substituting the value of T1 and T2 in the above equation. On substituting, we will be getting T1, we are writing it as 300 upon x minus 300 upon x plus 5, which is the time 2, equals to the difference of their timing, which is 2 hours. Now, as you can see here that 300 is common in the numerator. So, we will take out the common 300. We will be left with 1 upon x minus 1 upon x plus 5 equals to 2. Now, to simplify it further, we will be taking the LCM of x and x plus 5. 300 will be written as it is outside the bracket. In the denominator, we will be writing x multiplied by x plus 5. So, 1 will be multiplied by x plus 5. So, we will be writing x plus 5. Then the minus sign of subtraction. As you can see, we have x plus 5 here in the denominator. So, 1 will be multiplied by x. So, we will be writing x over here after subtraction. As we know it very well that the like terms with the opposite sign get cancelled. So, we will be cancelling positive x and negative x. We will be left with 300 into 5 upon x multiplied by x plus 5 equals to 2. As we have seen that in the denominator we are having x into x plus 5. So, we will be multiplying the numerators, which are 300 and 5. So, we will be getting 1500 in the numerator, and on multiplying x with x, we will be getting x square plus x multiplied by 5 will be equals to 5x equals to 2. Now, we will be interchanging 2 with x square plus 5x. We will be getting 1500 upon 2 equals to x square plus 5x. On simplifying 1500 by 2, we will be getting 750, which is equals to x square plus 5x. We can read it as x square plus 5x equals to 750. Now, we will be writing the given equation in the standard form by shifting 750 from RHS to LHS. So, we will be getting x square plus 5x minus 750 equals to 0. We got the quadratic equation. Since we need to find the original speed of the train, so we need to solve the given quadratic equation. We will be solving the given quadratic equation by factorization method, that is by using the splitting the middle term method. By using the splitting the middle term method, we want two numbers such that on multiplication I should get the product as minus 750, and by adding those two numbers I should get the sum as 5. When we are multiplying 30 into minus 25, our product is coming as minus 750, and on adding plus 30 and minus 25, we will be getting the sum as 5 over there. So, we will be splitting the middle term 5x as x square plus 30x minus 25x minus 750. Now, we will be grouping the first two terms together and the last two terms in one group. As you can see that in the first group, x is the common factor. So, we will take out a common factor x, which is multiplied by x plus 30. Now, we will be taking minus 25 as the common factor in the second group. So, we will be left with x, as we have taken minus common. So, inside the bracket we will be getting minus minus as plus over there, and 25 multiplied by 30 is 750. So, we will be writing here 30. Now, you can see that we are having x plus 30 as one of the factor and x minus 25 as the second factor, which will be equals to 0. Now, to get the solution from the given factors, we will be equating each factor equals to 0. So, on equating x plus 30 equals to 0, we will be getting the value of x equals to minus 30. And on equating x minus 25 equals to 0, we will be getting the value of x as plus 25. Now let us recall what we have assumed x in the beginning. We assume x to be the original speed of the train, and we know it very well. The speed of the train cannot be negative. So, we will be considering the positive value of x. Thus, we can conclude that the original speed of the train is equals to 25 km per hour. In this manner, you can find the original speed of the train by using the factorization method. I hope you must have understood the question very well, and it is very important question from exam point of view. Thank you everyone. Have a nice day.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.